Welcome to Finance and Excel video number 45. Hey, if you want to download this workbook for Chapter 6 or the PDF for Chapter 6, click on the link directly below the video and then scroll way down to the Finance class section. Hey, Chapter 6, we're going to talk mostly about bonds. What are bonds? Debt. That means you're taking out a loan. Now, there's always two sides to every transaction, right? One person's liability or debt is another person's asset. So we'll talk a lot about bonds, and we'll start off by talking about interest rates and inflation. All right, interest rates. We've got to talk about real versus nominal rates. Now, real rates, this is the percentage change in buying power, and we'll see a great example of that in just a moment. These are rates that have been adjusted downward for inflation. Nominal rates, this is like the rate you earn on your bank account. These rates have not been adjusted downward for inflation. This is the nominal rates, or the percentage change in the number of dollars that you have. Now, let's just, before we even go in and look at an example, let's just talk about what money is. Money is as money does. Well, that just means, the piece of paper isn't the thing, it's what it can do. So it's better to define money by its function. You can buy stuff with it. You get paid a wage. You can save it. So here are the three components, or the three aspects of money. Money acts as a medium of exchange. Right, without money, what would we do? We baked bread and someone else made shoes. So we'd have to go and hunt. If we wanted shoes, we'd have to go and hunt for someone who was willing to trade bread for shoes. That would be hard to do sometimes. All right, medium of exchange. A standard of value. I always think of it as standard or a gauge of value, or somehow a measure. So money is the unit in which the prices of goods and services are measured. For example, 20 units for a sweater. I just use units because money could be anything, right? Pennies, dollars, pounds, whatever. So you 20 units for the sweater, and this toy over here costs 10 units. Thus, you know that 2 toys equals 1 sweater. So a standard or a gauge of value. And finally, it can be a store of value, right? A person can hold the money and use it later. Hopefully they're putting it in the bank and earning an interest rate, which is what we're interested in. We want to see what happens when you save it. Let's first look at an example that concerns milk. And we're going to, from this example concerning milk, we're going to see inflation and the real rate, which is the change in your buying power. So here it is. January 1st, 2010, milk cost $3.39. 1 year later, it costs $3.56. Oh, the price went up. That's called inflation. So milk inflation in this simple example. By the way, calculating inflation is incredibly complex if you're doing it for the whole United States. It's just a simple example to get the idea. And it will help us illustrate the relationship between real rates and nominal rates and inflation. All right, so we started right here. This was $3.39. This is where we ended up. So we're going to use our formula we've been using ever since Chapter 00 in this class for proportional change or percentage change. The end divided by the begin minus 1. So we get this. So that tells us the inflation rate. Now, what if we go out on the 10th and buy 100 cartons, right? So we take this amount times 100. And this example here will help us figure out the real rate. So we have $339. That's our purchasing power right now, is to buy 100 cartons. So what if we didn't buy them, but we put in the bank and earn 10%? That's the nominal rate. We're going to use n equal 1. So nominal, this is what we earn on our savings. So APR nominal is 10%. January 1, 2011, the future value will be, that means the amount we have after 1 year, 372. Now, the extra interest added in here is nominal, right? It doesn't take into consideration, because we've increased our money by 10%. But what we're interested in is the purchasing power. right? So the question is, we earn 10%, but can we buy 10% more cartons of milk? We can buy 110 cartons of milk. I mean, can we buy 110 cartons of milk? Well, let's just look and see. Here's the amount we earned, right? That's our original amount plus all the inflation. And we're going to divide it by the new milk cost. This will give us the exact number of units, right? So now we have 104. Well, that certainly is 110, right? So the change in buying power, we compare this 4.75 extra, right, number of cartons to our original 100, and we get the change in buying power. Now, what's nice about this example is it's nice, it's concrete. We're doing number of units, right? We earned a nominal rate of 10%, but our buying power for milk went up only by 4.75. Now, we can express this relationship with something called the Fisher. Irving Fisher was a great economist in the early part of the 20th century. In fact, what he wrote about too much debt and financial and what can result in a financial crisis exactly predicted. He wrote this 100 years ago, exactly predicted what happened in our financial crisis. Anyway, he came up with this relationship. 1 plus the nominal equals 1 plus the real times 1 plus inflation. And there's our variables there. So we calculated an H of 5.05, this right here. So we can go ahead and plug this in to this equation, and we knew the 10% we earned it on our bank account, and then we can solve for this, right? And what do we get? Exactly the same thing. This is same as before when we did our milk example and counted the number of cartons we could buy. Now, what's great about this formula, of course, is you can solve for any one of these. So down here, I just show you a little deductive proof. We start there, and then we solve for R. So that's the formula for R, real, and we'll use that in just a moment. We start here, we solve for, and we get this formula for H, and also R. R, we just take minus 1 on the other side. Now, another way to manipulate this is if you multiply this out here, right? So 1 times 1 is 1. 1 times H is H. R times 1 is R, and R times H is there. Well, then we subtract this from both sides. We get 1 minus 1, so we're left with just these. And these components parts tell you what makes up nominal, right? So within our nominal rate that we're earning somewhere, there's the H. This is the compensation for decrease in value in original amount invested. The R, which is the real rate. And this little teeny extra bit here is the compensation for decrease in value of interest earned. Now, when the inflation rate is very small, this will be very small. And oftentimes they use this as an approximation, right? Whatever the inflation plus our real rate, and that gives us approximately what the nominal is. Now, I'm going to go over to Excel. I'm going to do, that's our second example. Let's go over to Excel. And I want to do this example here. Here's our same example we did in the PDFs. Milk now and 100 units. I want to multiply this and figure out what in the world, that's the amount we're going to put in the bank today. Here's our 10%. So I'm going to say, OK, no problem. I'm going to put that money in. That buys us 100 cartons. And our formula for future value given n equals 1 is simply 1, which always represents the principal, plus the interest rate. That always represents the extra interest added to the principal. Right? So now we can estimate our inflation, right? We can say, and this is a slight different calculation. I don't think we did this. Oh, yes, we did do this one over in the PDFs. But simply, we take end. That's the amount 1 year out, right? The n divided by the begin, and subtract 1. That's always our formula for proportional, or in our case, we have it formatted as percent, so percentage change. Now we have our H. Now let's go ahead, and this I just typed in here, 110 cartons, right? But again, all I did is I took the 100 cartons, and I multiplied by the 10%. That is the amount if we could buy 110, right? New cartons, then our actual buying power change would have been 10%. But no, we want to figure out how many actual cartons. So we say equals the total amount we have in our bank divided by the new price, right? This total amount right here is the 10% interest we earn. That's the nominal interest. And enter, control enter. So now we can see we can buy an actual number of cartons, 104. And so change in buying power is simply number of cartons divided by, where's my cartons? Oh, right there. And that gives us 1.5, sorry, minus 1. What? I got a different number here. Oh, don't get tricked. This is Excel, so that's just formatting. So I'm going to go increase the decimals up here. And we can see there is our change in buying power. Now that's our R, right? Change in buying power, the real rate. Well, let's use our Irving Fisher formula. Equals, and R, we simply take 1 plus our big R, which is nominal, divided by 1 plus inflation. 1 plus our nominal, divided by 1 plus our inflation rate. And then subtract 1. Notice this looks suspiciously like some end, some begin, and subtract 1. So it does look suspiciously like our percentage change or proportional change formula, right? So with that in mind, let's go back to our PDFs and look at the same example from a slightly different point of view. And we'll see that our Fisher formula actually does look like a percentage change formula. Here's our original milk cost. Here's the inflation, right? So milk cost $3.39, and 1 year later it cost $3.56. In our last example, we took this and multiplied it by 100, like we were buying 100 cartons of milk, right? But what if we just took this amount and just said, hey, we bought 1? Could we figure out what this amount is if we put it in the bank, right? So we multiply by 1 plus the nominal rate, and we get $3.72.9. We could then compare that amount. This is the milk original cost plus 10%. This is the milk original cost plus the inflation, right, which is the actual ending price. So here's our 1 plus the nominal rate. This is 1 plus the inflation. Subtract 1, we get the same thing. So if you can picture that, just a one single item, imagine if it was the milk cost $1, right? Then you could just see this formula, and this looks just like the Fisher formula, right? Instead of putting it in dollars, I left the dollar off because 1 times anything is just a thing, and we're left with 1 plus the inflation rate, or the nominal rate, divided by 1 plus the inflation rate minus 1. So that's the way I like to think of the Fisher effect, and it's the percentage change in buying power. So if we were to rewrite it, right, in textbooks we usually see it as, we saw it up here, right? Boop. But I always think of it just like a percentage change formula at least when I'm thinking about the real rate. So there it is. Again, I think of this top part as amount you would earn in 1 year at a nominal rate. And this bottom part is what you could purchase given an inflation rate. R is the percentage change in buying power. So let's look at a couple examples. Here's our 2 examples. We're going to look in inside the PDFs, but I'm going to go over to Excel. And I'm going to click on the sheet 3, 4, and 5. All right, so let's use our formula, our Fisher formula. Percentage change in buying power. There's our rate we could earn, nominal. There's our inflation, equals, 1 plus the nominal divided by 1 plus the inflation rate. Oh, and then subtract 1. And even though this isn't like, in terms of time, the end amount and the begin amount, I can picture it that way because this is just adding just the inflation, and this is the nominal. Okay, so we do that formula, and boom, it tells us the increase in purchasing power. And of course, this is important because if you're investing, right, you want to at least try and beat the inflation rate. This is I'm shooting this in 2010. And this is an interesting time because what? Inflation is 1%, right? So if you want to increase your real purchasing power, it doesn't take much to beat that about 1% inflation rate. Now let's look at two other examples. What if we could earn 1% on our savings account, but inflation went up, right? What would the rate be here? 1 plus nominal divided by 1 plus inflation. And then subtract 1. Whoa, negative. Now, so right now, this in 2010, some savings accounts are just barely paying 1%, and inflation is about 1, maybe a little bit above. This is 1.5%, right? So this scenario is real. It even becomes more real if you think sometimes if you're investing in stocks or bonds, what if you have a terrible year and your return, which is a nominal return, is negative, right? Then this situation definitely could happen, which means your real purchasing power goes down. Now let's look at, notice we start at, we have a nominal rate of 1 and then an inflation of 1.5. But what about slightly reversed? The nominal rate, so we can earn 1.5% on our savings account, but inflation goes up by 1%. Notice the difference between both of these is 0.5%, right? Or yeah, 0.5%. So let's go ahead and see what our change in purchasing power is, which is the real rate. So 1 plus nominal divided by 1 plus our inflation minus 1. You would think that these would be exactly the same, right? But the difference is this is going down. We have a loss. And so this number is going to be a little bit smaller than going up, right? We had inflation of 1, but we earned a little bit more in our nominal rate. And this is always true. Anytime you're going up, you have the potential to think of it in huge terms. Can you increase 100% going up? Right? Yes. How about 200%? Sure, going up. You could have, over 10 years, your portfolio of investments could go up by 100 or 200, 300. But going down, you never can go down further than 100%. So that's why, even though the distance between nominal inflation is both 0.5%, this one has to be smaller than this one because this one is going up. All right, that's a little bit about interest rates, real and nominal. When we come back in our next video, we'll start talking about bonds. All right, see you next video.